Hello everyone. Today we'll be solving Aqa GCSE Chemistry Paper 2F. This is a Specimen 2018 paper. Today we're going to be solving part 2 of the question paper. This question paper consists of 12 questions. Today we'll be solving from question number 7 to question number 12. Nitrogen and hydrogen are passed over iron to produce ammonia in the Haber process. The equation for the reaction. We can see there are 3 hydrogen on this side and there are 2 hydrogen on the left side. So let's put 3 in front of the hydrogen, which makes it a total of 6 hydrogen in the left side. So we can put a 2 in front of the ammonia, which makes 6 hydrogen and 2 nitrogen. The 2 nitrogen is balanced with N2. What is iron used for in the Haber process? Iron is used as a catalyst. This will be the answer. Figure 8 shows how the percentage yield of ammonia changes with pressure. Percentage yield of ammonia, and as the pressure in atmospheric pressure is increasing. We can see as we keep on increasing the atmospheric pressure, the percentage yield is also increasing for the ammonia. Guys, if you don't know what is percentage yield, it is the amount of or the percentage of product that is left at the end of the reaction. The remainder of it, they are unreacted. When you see a percentage of 40% yield, that means 40% has turned into product, the remainder did not turn into product. Describe the trend shown in figure 8. So the trend, as pressure increases, percentage yield increases. Use figure 8 to determine the difference in percentage yield of ammonia at 150 atmospheres pressure and 250 atmosphere pressure. Difference in percentage yield of ammonia, 100 and 150 and 250. First of all, whenever a question like this comes, please do a data quote. So we're going to quote the data of 150. So that gives us 23 and 250. That gives us 32. Then we will do 32 minus 23 equals to 9%. This question is about hydrocarbons. The name and formula of 3 hydrocarbons in the same homologous series are ethane, propane, butane. The next number in the series is pentane. What is the formula of pentane? Pent means 5, so C5. C4 is H10, so C5 will be H12. By the way, alkane goes by a general formula of CnH2n plus 2. You can remember it. This is alkane. Which homologous series contain ethane, propane, and butane? So we already talked about it. These are alkanes. Propane is used as a fuel. Complete the equation for the complete combustion of propane. So if we have C3, definitely we're going to produce 3CO2, and H8 will produce 4H2O. Because when we will multiply 4 with H2, it becomes 8 hydrogen. Octane is a hydrocarbon, C8H18, found in petrol. Explain why octane is a hydrocarbon. Okay, any compound that contains only hydrogen and only carbon, that's why we call it hydrocarbon. Table 3 gives information about the pollutants produced by cars using diesel or petrol as a fuel. Diesel, oxides of nitrogen 31, particulate matter 100, carbon dioxide 85, petrol, oxides of nitrogen 23, and carbon dioxide 100. Compare the pollutants from cars using diesel with those cars using petrol. In cars using petrol, you can see there are no particulate matter. Diesel produces oxides of nitrogen more than that of petrol and produces more particulate matter, which is way higher than that of petrol, and produces less carbon dioxide, however, in diesel. Because of incomplete combustion, actually, the carbon dioxide percentage is less, which is not a good thing, which is a bad thing. Pollutants cause environmental impacts. Draw one line from each pollutant to the environmental impact caused by the pollutant. So oxides of nitrogen. Oxides of nitrogen are mainly responsible for acid rain. Particulate matter. Particulate matter are dusty and they're very much responsible for global dimming. A student investigated the rate of reaction between marble chips and hydrochloric acid. Figure 9 shows the apparatus used by the student. So bubbles of carbon dioxide are produced. 40 cm3 of hydrochloric acid, 20 gram of marble chip, and conical flask with A. Balance is, so as the carbon dioxide escapes this particular reaction, we will be able to measure how much mass has decreased. What is A? A is cotton wool. This cotton wool is actually used because to prevent it from spitting. Table 4 shows the student's result for one investigation. We can see the time in seconds, mass lost up to 4 grams. Plot the results on the tree. Draw a line of best fit. Use figure 10 to complete the table 5. Mass lost after 0.5 minutes. So 0.5 minutes means 30 seconds. So we will do an extrapolation at that and we will get 2.1. Time taken to complete the reaction. We can see that at 100 seconds, the reaction is completed because at 120, the result is also the same. The equation for the reaction is HCl plus calcium carbonate, calcium chloride, water, CO2. Explain why there is a loss in mass in this investigation. Because we're producing CO2 as a gas which can escape from the flask. Another student investigated the rate of a different reaction. Table 6 shows the results from the different reaction. Mass lost when reaction was complete 9.85. Time taken to complete the reaction, 2 minutes 30 seconds. Calculate the mean rate of the reaction using table 6 and the equation. Mean rate of reaction is mass lost in grams divided by time taken. 1 minute is equals to 60 seconds, so 2 minutes is equals to 2 times 60 plus 30. 9.85 divided by 150 gives us 0.065. The student measured the change in mass of the reactant. Describe another method other than measuring the change in mass of the reactions that the student could have used to find the rate of reaction between marble chips or hydrochloric acid. Another method can be the gas that's produced can be collected. So the gas is collected in a gas syringe, and then the volume of the gas is measured. That will be equal to the number of moles of gases that is produced. Now, the student planned to investigate the effect of temperature on the rate of reaction. The student predicted that the rate of reaction would increase as the temperature was increased. Give 2 reasons why the student's prediction is correct. When we increase temperature, the particles usually have more amount of energy. That is the main reason. All right, increasing temperature increases energy of the particles. Surface area or mass or more concentration or particles moving faster. All right, at higher temperature, particle also moves faster. So both of these are correct. Water from a lake in the UK is used to produce drinking water. What are the 2 main steps used to treat water from lakes? Give a reason for each step. First of all, when we are collecting the water from a lake, we must filter it so that we can, remove large bits of solids like, plant matters and, a sand, whatnot present in water. We can remove them. The next process will be sterilization. So the step 2 will be sterilization to kill the microbes. And step 1 will be filtration to remove the solids that comes with the water. Explain why it is more difficult to produce drinking water from wastewater than from water in lakes. Water needs more different processes because it contains any thing like, for example, organic matter, microbes, toxic chemicals, or like detergent can get mixed. Some countries make drinking water from seawater. Complete figure 11 to show how you can distill salt solution to produce and collect pure water. Label the following: pure water, salt solution. How could the water be tested to show it's pure? Give the expected result for the test for pure water. The water can be tested using the determination of boiling point because pure water has a fixed boiling point of 100 degrees Celsius. Why is producing drinking water from seawater expensive? To produce drinking water from seawater, we have to do process like distillation, which requires a lot of energy. Figure 12 shows 6 test tubes a student set up to investigate the rusting of iron. This is the method used for each test tube. Measure the mass of the nail using a balance. Leave the nail in the test tube for 6 days. Measure the mass of nail after 6 days. Test tube 1, test tube 2, test tube 3. Iron nail, water, iron nail in dry air, iron nail in water with oil on top of it. Test tube 4, we have a painted iron nail in water, painted iron nail which is scratched, then put into water, and a galvanized iron nail which is scratched and put into water. You can see the mass of the nail gram in each different test tube, and some of them increased in mass. What is the resolution of the balance student used? In this case, we can see the student uses a particular balance that is correct up until 2 decimal places. So since it is correct up until 2 decimal places, we can say that it is correct to the 0.01 gram, which means 1 into 10 to the power of minus 2. Calculate the difference in percentage increase in mass after 6 days of the nail in test tube 1 and the nail in test tube 5. Give your answer to 3 significant figures. Calculate the difference in percentage increase in mass after 6 days of the nail in test tube 1 and in test tube 5. First of all, we can talk about test tube 1. We can see there is an increase in mass. 0.91 minus 8.45 divided by the original mass that we started from into 100% will give us the percentage increase, which is 5.44%. In test tube 5, you can see the mass has increased only by a little bit. 9.45 minus 9.37 divided by 9.37 into 100%, which gives us a value of 0.854. If we have to do the difference in percentage, we have to do 5.44 minus 0.854, 4.586 or 4.59. Use the results of the student's investigation to draw a conclusion about the factors affecting the rusting of iron. Include an evaluation of the effectiveness of different coatings at preventing the rusting of iron. We can see that in test tube 1 and 5, the nail got rusted, because there was an increase in mass. Use the results of the student's investigation to draw the conclusion about the factors affecting the rusting of iron. Include an evaluation of the effectiveness of different coatings at preventing the rusting of iron. To answer this particular question, we will have to make statements about what happened in those test tubes. When we see the data from the table, in the table, we can see, all right, the nail got rusted in test tube 1 and 5. Test tubes 1 and 4 contain air, oxygen, and water, but the nail did not rust in test tube 2, 3, and 4. The test tube 2 has no water present. Test tube 3 had no air or oxygen present. And test tube 4, the paint stopped it from rusting. And in test tube 6, the scratched galvanized iron did not rust because galvanizing stops from rusting. So the conclusion is both water and oxygen are required together for rusting. Coating that prevents water and oxygen from reaching the metal will prevent it from rusting. And when paint is scratched, iron comes into contact with water and oxygen and the iron rusts. In test tube 5, less iron is exposed, so less rusting than in test tube 1, definitely, because it was painted and it got scratched and only the scratch was exposed. And then galvanizing is better at resisting rusting, because even when the galvanizing is scratched, all right, it still protects the metal within it. Zinc is more reactive than iron, so when galvanized metal is scratched, zinc reacts with water and oxygen first, and this is kind of a sacrificial protection. Finally, oil and paint are effective in preventing rusting when the coating is intact. Galvanizing is the most effective effective coating because it prevents rusting even when it gets scratched. Rust is hydrated iron 3 oxide. Complete the word equation for the reaction. So iron plus oxygen plus water produces hydrated iron 3 oxide. Plastic and glass can be used to make milk bottles. Shows the percentage of milk bottles made from glass between 1975 and 2010. Plot the points and draw a line on figure 13 to show the percentage of milk bottles made from materials other than glass between 1975 to 2010. Guys, in a question like this, we have to consider that every bottles that are made, that is equals to 100%. So if 95% of the bottles are made from glass, then only 5% is made from other materials. So we will label 5% in 1970. Then 90 will give us 10. 1985, we can see that it is 78. 78, so that will be 22. It's just the opposite, inverse. 1990, all right, it will be 42. So guys, how we solve this particular question was as follows. When 95% of the bottles were made from glass, then the remainder of the material, the remainder of the bottles were made from the rest of the 5% was like the other materials, all right, and then we continued. So since this was 90, so that's why this was 10. Total is 100. Since this is 78, all right, so that's why it was 22. The total should be always equals to 100. Evaluate gives the information about milk bottles, raw materials, sand, limestone, salt, bottle material, soda lime, glass, and we can see a total process percentage of recycled material used in new bottles, 50%. We can see that plastic milk bottles are less recycled, but the size of the bottles can come in many different shapes. Evaluate the production and use of bottles made from soda lime, glass, and those made from HT polythene or milk bottles. So when using glass, all right, glasses have 2 stages of production for soda lime glass, all right. The second stage is heating the sand, limestone, and sodium carbonate. HDPE has 3 stages of production. The second stage is cracking of naphtha to obtain the ethene. And the third stage is polymerization of ethene. Fewer stages in glass production, so maybe quicker. Higher temperature in glass manufacture, therefore it requires a lot more energy than compared to that of plastic milk bottles. And we can say that glass bottles can be reused more because you can see 50% of it is reused, whereas plastic bottles are reused less. Other glass products can be made from recycled glass as well. Plastic can have greater ranges for sizes. As you can see, we can have many different sizes up to 3 dm³ or 3 liters. Plastic has greater ranges of sizes, both produced from limited raw materials. So in that case, we will run out of sand that actually is needed for making the glass, silica. And in the case for plastic, we'll run out of the crude oil needed the polythene. So higher percentage of recycled material can help to conserve raw materials in the production of glass milk bottles. Guys, that's all for the question paper. Thank you for watching the video and see you in the next video. Best of luck for the exam.